So boys and girls, we move on to question 8. Question 8 is about topic 9, quantizations of light. So the question gives us the work function of sodium is 2.3 eV. A. Calculate the stopping potential when the frequency of incident light is 6 to the power of 14 Hz. So the question gives us the frequency of incident light 6 to the power of 14 Hz and the work functions 2.3 eV. So we want to find the stopping potential Vs. Okay, so if we refer to the list of equations, we are given the work function W0, we are given the frequency of the light, so we want to find work stopping potential Vs. So refer to the list of formula for topic 9. So we are going to use equation 83. Okay, we are going to use equation 83 whereby Kmax is equal to EVS, which is equal to HF minus W0, the work function. So we are going to use equation 83. So we have EVS equal to HF minus W0. So rearrange the equations. So the stopping potential Vs will be HF minus W0 over E. E is referred to the elementary charge. You can get the value from the list of constant. Okay, so H is Planck constant. Put in all the value. Planck constant 6.63 to the power of negative 34. The frequency of the incident light is 6 to the power of 14. Minus the work function is 2.3 eV. So bear in mind, the work function in eV, we must change it to joule. So the 2.3 eV, we have to multiply with 1.6 to the power of negative 19. Okay, divide by the elementary charge, 1.6 to the power of negative 19. So do the calculation, you will get the stopping potential will be 0.19 volt. Okay, so substitution 1 marks, answer with correct unit 1 mark. Okay, then we proceed to question 8b. Okay, question 8b. If a 600 nanometer light strike on the sodium surface, so now I have a photon light with wavelength 600 nanometer. I strike on the sodium, whereby the work function for sodium is 2.3 eV. So will the photoelectron be ejected? Justify your answer. So the question asks you, when the light strike on the metal surface, is there any photoelectron ejected, being emitted? So we understood that in order to eject an electron from the metal surface, the energy of the photon, the incoming light, must greater than work function. Then only photoelectron will be ejected. So in order to answer this question, untuk jawab soalan ni, kita perlu kira what is the energy carried by the light, which is the wavelength is 600 nanometer. So kita perlu kira dulu energy photon untuk wavelength 600 nanometer. Then we check whether the value is greater than work function or less than work function. Dari situ kita boleh tahu sama ada photoelectron is ejected or not. Okay, so we are going to do our calculations by using the equations. The equation we use to calculate the energy of a photon is equation 80. E is HF or equal to hc over lambda. Okay, so we use equation 80. Energy of the photon is hc over lambda. So we have 6.63 to the power of negative 34 times c, speed of light 3 to the power of 8, divide by the wavelength 600 nanometer, so times 10 negative 9 meter. So when I do the calculation, I get the energy of the photon is 3.315 to the power of negative 19 joule. Okay, because I want to compare it with the word function, whereby the question gives the word function in electron volt. So I convert the energy of the photon to eV. So I divide by 1.6 to the power of negative 19. So I get the energy of the photon will be 2.1, around 2.1 eV. Okay, so compare with the word function of sodium, which is 2.3 eV. So since the energy of the incoming light photon is less than the value of word function, so there will be no electron ejected. Why? Because the energy of the photon is only 2.1 eV, but the word function, whereby the word function for the sodium, the word function given in this question for sodium is 2.3 eV. So the value is less than word function, so there will be no photoelectron ejected.